Okay guys, welcome to Developers and Coders Club. Today we are gonna see the problem permutation subsequence of the CodeChef contest starters 80B. As you guys can see, I have already solved this problem and now I'm gonna explain how to crack it to you guys. So in this problem, the statement is given as the Shafina has an array A consisting of n positive integers. A permutation subsequence of length m is a subsequence that represents a permutation of length m. Now Shafina asks Chef to find the count of permutation subsequences in array A. The count can be very large, so output it modulo 10 to raised to the power 9 plus 7. Now, why, if you guys are wondering why it is 10 raised to the power 9 plus 7 only, then I must tell you it is a prime number just after 10 raised to the power 9. Okay, then as a reminder, a subsequence of an array is what? But nothing but obtained by deleting some, possibly zero even, elements from the array without changing the order of the remaining elements. And what is a permutation? A permutation of length m is an array of length m in which every element from 1 to m occurs exactly once. That is, if I ask you to write a permutation till 4, 1 2 3 4, 1 4 3 2, 2 4 3 1, 3 1 4 2, all these are possible permutations. Like it can't be 1 2 3 5, it that can't be the case, and 1 2 4 4, that cannot be the case. Now, what is the input format? So the input format is the first line of input will contain a single integer t denoting the number of test cases. Then in each test case, the first line will represent an integer n, which would be the length of the array. The next line contain n separate integers, which are nothing but the elements of the array. Now, for input, in each new line, we have to print the count of permutation subsequences in array A modulo 10 raised to the power 9 plus 7. Now, what is this 10 raised to the power 9 plus 7? We will check that later. First, we have to focus on the count of permutation subsequences. This we will focus when we will tackle the larger test cases. Now, what are the constraints? T will lie between 1 to 2 into 10 raised to the power 5. Similarly, n will lie in the same range as well. AI will lie between 1 in, uh, and 10 raised to the power 9. Then sum of n over all test cases does not exceed 2 into 10 raised to the power 5. That is, if we do a loop on t and inside it we do a loop on n, then the multiplication won't exceed 2 raised to into 10 raised to the power 5. The test cases would be given in such a fashion. Now, what are the sample test cases? We have been set of two cases as sample test case, and its output is also given. Now, let us first try to understand the problem in a better way. So, suppose we have been given an array of size 5, like 1, 2, 3, 4, 5. Then, what could be the possible permutations we can form from the subsequence of this array? It could be 1, choosing just the first index, or it could be 1 and 2, or it could be 1 and 2 and 3, or it could be 1 and 2 and 3 and 4, or it could be 1 and 2 and 3 and 4 and 5. So our answer could be what? Nothing but 5. But what if there is one more repetition of 1? What do you think it will do? When we will try to select the subsequence now, these 5 would be there because we are building permutation, so no repetition is allowed. Keeping that in mind, these 5 will be there, but there will be 5 more. Why? Because this time we won't be taking this one. Instead, we will be taking this one. So what will it do? 1, 2, no, starting from 1, then 1, 2, then 1, 2, 3, then 1, 2, 3, 4, then 1, 2, 3, 4, 5. So how it would be? It would be like 1 again corresponding to this one now. Then it would be 2 and 1, then it would be 2 and 3 and 1, then it would be 2 and 3 and 4 and 1, then it would be 2 and 3 and 4 and 5 and 1. So this is how it is gonna be. But what if instead of 1 there was 2 in here? if instead of 1 there would have been 2, then apart from these 5 cases, what could be the possible subsequences? Now, this time, this 1 won't be there because there is no repetition of 1. But rest of these can be found because instead of using this 2, we can use this 2. So we also found out that if 1 is affected, if one more duplicate element of 1 is there, then it would affect 5 subsequences. But in the case of 2, if one more duplicacy is there, then it will only affect the 4 cases because this one won't be there. Similarly, you can find out that if it is 3, then it would only affect 3 because only these 3 would be affected because only these 3 contains the 3 as an element. Similarly, for 4, it would only affect 2 cases because only these 2 contains 4. And then for 5, obviously it would be 1. So what pattern we are observing from here, that the number of subsequences which will contain the specific element, those many subsequences will be affected by its duplication. So if I say कि I had 3 such duplicate elements of 1, like there are 3 ones in the array. So what does it refers to? That there would be 15 as the answer. Let me put that again what I'm saying. I'm saying that there is an array 1, 2, 3, 4, 5, 1, 1. And I'm asking you how many possible permutations are there. So your answer would be nothing but 15. Why? Because for 1, 1, I got 5. But instead of choosing this one, I could also choose this, or I could also choose this. So how much it would be? 1 1 is affecting 5, so 3 1 is affecting 15 subsequences. So our count would be 15. Okay. So similarly, if I got 3 1 and 2 2s, what would be our case? This could be one possible test case. Or these were some simple test cases. We could move towards some complex test cases, like what if 5 is not there? So let us try to analyze those. Okay, so let us now assume that this 5 was never there. Instead of this, 6 was there. So what happens? This can't be there. And further in the array, no matter how many else numbers are written, like 7, 6, 8, 9, 10, 11, we don't care because we can only write till 4. Only these 4 subsequences will be there. It doesn't matter that if 5 is not there, then after 5 how many integers are written there. It doesn't matter because it will not form a permutation because 5 is missing. So what do we observe from here? That the first integer, while moving consecutively from 1, the first integer that will be missing, after that, including that, we won't be checking. Like we won't be checking for 6, 8, 9, 10, and 11 because we know 5 is missing. So a permutation cannot be formed from here. Okay, so all these test cases are analyzed. Now let us move to the final edge case. Like if there is 1 2 and let us say there are 4 4, I mean 3 fours. So what could be the possible answer? So in this case we can analyze, like let us first write that in a sorted fashion for better understanding. This is how it is. So in this case we can analyze what could be the things. It could be 1, or it could be 1 2, or it could be 1 2 3, or it could be 1 2 3 4. These 4 can be basic subsequences. Now due to duplicacy, what happens that 2 more copies of these 3 are made. Okay, and due to three duplication, the frequency of 4 in this array being 3, what is gonna happen then? How many times 4 has occurred? It has occurred 2 times. So 3 copies of these two would be created. 3 copies of these two. So it would not be 3, it would be 3 into 2. That is 6 times these 1, 2, 3, 4 would be present. Uh, just a second. So this would be the case. Let us take it again. First, we got these 4 basic things. Then we checked out how many subsequences this 2 is affecting. So this 2 is affecting 3 of those subsequences. So we repeated those 3, 1, 2, 1, 2, 3, and 1, 2, 3, 4. Then we tried to find out among what we have written till now, how many of them are affected by the 4. So 2 of them were affected by 4, and of these 2, there are 3 copies of 4. So 2 into 3 is 6. So 1, 2, 3, 4, 5, 6. So this is the total number of subsequences that we'll have, which would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the answer would be 11. Now, as we have understood the basic logic behind the code, now let us try to implement it. Okay, so first I included the header file. Then these are some part of the user snippet I use, where ln stands for long, which is of work in here, and fn is for a for loop from I to n, and el accounts for the cout and l. Now let us check the code. First we come in the int main, then we take the input of the test cases, then we went inside the while loop that will account for the number of test cases. Then we took input for n, which is this size of the array. Then we constitute an array A. Then we constitute a set. Why it is being constituted, we will see that later. Similarly, we have also taken a map. Now, both of their uses I would tell later. Now, what we did, we take the input in the array and then inserted it in map. Now, what it would do, it would create a hash table. What do we mean by hash table? It is nothing but a frequency table. It will tell me what is the count of each element that is occurring, like how many ones are there, how many twos are there, how many threes are there, how many fours are there in the whole array. This is what this map will do. Now what else we did, we inserted it in the set. Why in the set? Because set will when we will insert it in set, all the array elements would be the only those which are distinct would come in it. So what does that mean? If this is 1, 2, 3, 2, 4, then in the set it would be only 1, 2, 3, and 4, and that too in the sorted fashion. Then we created an integer c is equals to 1 and sm is equals to 0. Now we traversed in the loop in the set, inside the set, and we are using this loop trying to find out the first integer which is not in the array. What are we trying to do? Find the first integer which is not in the array, as we have seen in the case when 5 was not there. So it doesn't matter ki 6, 8, 9, 10 what is written, all of it doesn't matters. If we find out that 5 is not there, we are not gonna check ahead of that. We are not gonna check ahead of 5. So for finding this number 5, we are doing this, that which is the number which is not in the array, because when we have put it this array elements in the set we have 1, 2, 3, and 4 only. So that we checked starting from I. Now, if I is not equal to C, C is initiated with 1. So if the first element of the set is not equal to 1, then break, else we increase C, then it checked for 2, then 3, then 4, and so on and so forth. Now finally, when we got 5, we did an SM minus minus, so that we know what is the last element, what is the last integer till which all the integers from 1 to that integer are there. So we got 5 in SM, then we did an SM minus minus to know that till 4, 1, 2, 3, and 4, all elements are there in the array. Then we made another array, LL array, which is nothing but array. What does this account for? This account for how many subsequences a single element is gonna affect, as we have seen in our this understanding that 1 is affecting 4 subsequences, 2 is affecting 3 subsequences, 3 is affecting 2 subsequences, 4 is affecting 1 subsequence. So what did we find? That if SM is equals to 4, if SM is equals to 4 as currently from here, the number of subsequences that 1 is gonna affect is equals to SM, isn't it? So that is what has been done by this loop. It provides the value of 4 to 1, 3 to 2, 2 to 3, and 1 to 4. See, so we exactly know how many subsequences each element is gonna affect. Then we made another variable s, which is equal to 0, and product, which is equal to 1. Now what we are doing? We are just doing what we discussed. We initialize from 1 to SM, that we initialize from 1 to 4, and then we in the integer product, which is equal to 1, we multiplied it with the frequency it is in the array. As we have seen in this test case, 1, 2, 3, 2, 4, 1 is only 1 times, so the product value would be what? In this case, 1 into 1, which would be 1. And let us just skip these two lines for now. I will discuss them later. Then what will it do? S is initiated from 0, so it will add 1 to it, so it will become also 1. Then it would go in the next call, it will go for 2. Now what is the frequency of 2 in the array? It is 2, and the product is already 1, so it will be 1 into 2 is equals to 2. Now sum is already equal to 1, and it will add 2 to it, so it will become what? 3. Now it will move to the next element, which is 3. Product is already 2, but the frequency of 3 in the array is just 1. So it would be 2 into 1, again 2 only. Now when we will move to this line, S is already 3 and we add 2 to it, it will get 5. Now coming to the 4. Now what happened to when I will reach 4? The frequency of 4 in this array is 1, so it would be 1 into product is already 2, so 2 into 1, that is 2 only. Again it would be added to s, so it will become 7, which will be printed as our answer. So this was the implementation of this code. Now moving on to the final part, what to do with this modulo. We can see as the frequency of each element will increase, the product will get multiplied with a larger and larger number. And as it will become large, so it can go out of bound. It can go higher than 10 raised to the power 9. So that's why we are doing this modulo operation, to always keep it in range. And as we are adding it to sum, so sum can also go out of bound. So to keep that in the range, we are also doing a modulo operation in here before printing it. So that was the whole crux of this question. As I have discussed, I hope you guys understood it. Thank you so much, guys.